Okay, so let's go through the starter question here. So we've got three statements here, and I just explained what a complementary angle is. So we said complementary angles would add to 90 degree. Okay, so let's have a look at statement 2. Y and 47 are complementary. So I can see that I've got angle Y here, and I've been told that I've got 90 degree here. Because you've got a straight line, so you definitely got 90 degree here. So that means Y plus 47 equal 90 degree. So that statement is true. Now, angle Z and 47 are supplementary. So let's find out. So Z is the orange angle. So it starts from there right up to there. So I can see that if I do Z plus 47, I get 180. So that statement is true as well. So hopefully, statement number 1 is the lie. So what they're telling us is there's not enough information. If it's a lie, that means we do have enough information. Okay, so let's check that. To find the angle X, I've got 47. I've been given here a right angle 90 degree, and I've got X. That means 47 plus 90 plus X should be equal to 180. And to get X, you would just put in your calculator 180, take away 90 plus 47, which is 43 degree. So we do have enough information. So the lie is number 1. Any question with that? Okay, so I wanted to mention this complementary angle because we're going to be talking about trig equations at one point, or trig graphs. You will see trig graphs. So trig are everything to do with some sine waves and cosine waves. So if you've got a sine wave, okay, the cosine wave is technically CO stand for complementary. Complementary of sine. Which mean when we're going to calculate, or on your calculator, you see a sine button. When you're going to do sine of an angle, let's say you do sine of 60 degree, it's going to be equal to cosine of the complementary of 60, which is 30 degree. So if you've got your calculator, you can check that and it will work because the two angles are complementary, and cosine just means the complementary of sine. Okay, so that's why I wanted to mention that. Okay, any questions before we move on?
No.
Okay, good. So what we're going to be looking at today, so hopefully the lesson shouldn't be too long. I hope it's going to be within the hour. It's probably going to be the fastest we've done so far. And someone asked me, when is the next time we're back in on campus? So it's during that mini prelim. So again, the mini prelim is a closed book prelim. Okay, so that's why we've got to do it in-house. And so that you know as well, the mini prelim will have enough subject-wise that we could take the mini prelim as an evidence in case something would happen, like the SQA decide there's a new variant that came, we can't do exams as per the SQA, we're going to have to show evidence on your work. So just so that you know, guys, the mini prelim is SQA based mini prelim. So they'll take that as an evidence work if it's required. Okay, so to give you my best advice, you should be trying to do as best as you can, because we don't know what's going to happen. Okay, so if we can't take it as an evidence, then it's a shame. But you will have another prelim after this mini prelim. It's called mini prelim because there are still two topics, 2 or 3 topics that are not going to be touched. Okay. Any question with that?
No.
Okay. And to be honest, anything with prelim in schools, let's say you do your mini prelim and your prelim and you do really well, and for some reason you have a really bad day during SQA exam, you can always ask reconsideration or something based on the work that you've done during the year. So an appeal, for example, might be able to use the mini prelim and the prelim. Okay, so they could be used for appealing because there's enough content in them. All right, we never know. You could be in the SQA exam having something that cause you not to be able to turn up. Okay, so for today, we're going to look at the homework, changing the subject. So I'm going to spend some time going through it, because from what I've seen, based on your homework, guys, there are still people, struggling with it. So hopefully we'll be able to nail a few misconceptions out of it. I will mention something about quadratic graphs, recap and further questions, just to help you in the lessons that are online just now. We'll look at a past paper question to give you an idea. So this week's work is quadratic functions, and you're going to use what we did in the first unit, ENF. And one of the teacher put the mixed exam type questions from relationships part 1. So it's a good overall. Again, guys, the homeworks are more for you to see where you're at, what you still need to work on. I've seen some people giving their homework more attention than others. We all guilty sometimes of procrastinating, waiting for the last minute to do something. If you put some time to do these, remember your homework, you're allowed to open your book. They're not closed book. So you're allowed to see what notes can I use to help me with this question, for example. Those are all techniques to use. So like I said, you're not going to get into trouble for not doing them. But if you want to make the best of the money that you've invested to come and do this course, is try and check yourself, test yourself, see where you're at. And then when I see something that I could help, I'll talk about them today, for example. And I'm not going to mention a name to say this person, you will probably recognize as you go, oh, that was a mistake that I was making. So, but it's more for you to get out of something here. Okay. And remember, if you got any questions again during the week or just now, you can, raise your hand or put it in the chat. I'll try and answer it as much as I can. Okay, so without further ado, let's have a look at the first question. So the first question in your homework was, we have a formula for changing from degree Celsius, so degree C, to degree Fahrenheit. So what does that mean? If someone is in the States and tells me, oh, it's 85 degree at the moment, there is not a chance that that person is telling you it's 85 degrees C, right? Because it's like being in an oven. So how can you find what 85 degree Fahrenheit is in degrees Celsius? Can someone tell me? Using this formula. $85, you plug it where it says F, and you get your temperature in degrees C. So let's have a look. If I do 5, so if I do 5/9 in my calculator, time 85, and then take away 32, my calculator gives me, so 5/9 time 85 minus 32, 137. Oh, that's a bit cold. 137/9, which is 15.2 degrees. So 85 is quite cold. Yeah, I thought it'd be a bit more than that. So what about 95? 95 would be, yeah, 21 degree. So 95 degree is quite, Fahrenheit is quite nice, it's 21, but 85 is probably during the winter. So you see, I wasn't too aware of that, but straight away, now you know, if someone in the state is telling you it's 85, it's about quite chill, okay? 15. Might not be that cold in Scotland, especially today, but there you go. That's why you get formulas, okay? So now I've been asked to change the subject of the formula to F. That means if you've got someone in America, that person would need F equal something to find out if I tell the person, oh, it's 25 degrees here, what would that be in Fahrenheit? That's all it is to be able to find this time what is the degree in Fahrenheit if someone tells me what the degree is in Celsius, degrees Celsius. So we need now to extract F from here. Okay, so to do that, we do the inverse of what happened to F. So think about F here. What did we do to F? We've timed F by 5. Yeah. So F got timed by 5. Whatever we had, we divided it by 9. And then we took away 32. So that's what we did to F to get this formula. So to do the inverse operation, I'm going to do the opposite of all these. The opposite of taking away 32. So we're going to now add 32. We're going to time by 9. And we're going to divide by 5. So if you do those 3 operations, you'll get your 3 marks. Because this question was 3 marks. So I've got to do 3 things to get my 3 marks. So what you hear sometime, someone would tell you, I've got a minus 32. If I put it on the other side, it becomes plus 32. So 2 school of thought, I could just do it like that. I can just say, I'm going to add 32 to both sides. So if I'm starting with, so I've seen someone even changing F on the left because they like to have F on that side. So that's fine. If you didn't do it that way, that's perfectly okay. So the first thing you will do is you're going to add 32 first. But if you add 32 on one side, you need to add 32 on the other side. And by doing so, you will get rid of the 32. Because minus 32 plus 32 is 0. So you end up with 5/9F equal C plus 32. That's what we've done. Adding 32, and you get your first mark. Now, what did we say we do next? We're going to time by 9. obviously I've got a divide by 9. The opposite of dividing by 9 is timing by 9. So I'm going to time by 9 both sides of my equation. But this is the bit where people lose a mark, because sometimes they don't think about C plus 32 as being one big quantity. So for you now to stop this happening, whenever you're going to have part of your equation with adding things, just put the two brackets. Okay, so if you get to that habit of putting the two brackets, that will save you a mistake that is commonly made. So the next thing I said, I'm going to time by 9. So if I time by 9 here, 9 times 5 divided by 9, I get 9 divided by 9, which is 1. So you end up, that's what we do, 5f equal 9. Because you've opened the bracket, you're not going to forget it, C plus 32. And that is your second mark. So 2 marks out of 3, you've passed your first question. You could stop here, and if you do this for every single question, you get more than half of your mark. You can go through the full paper and get a pass at the end. So we've not finished, but we've got 2 out of 3. But we're going to get the third mark because it's one of the easiest one. And what I said, we do it in the order, add 32, time 9, and the last thing we're going to do is divide by 5. So usually what I say to folks solving equation, I've got 5 times f. That's what 5f means. What is the opposite of timing by 5? And then you hear them all saying to me, divide by 5. And that's what they do. They divide by 5 both sides. And to divide by 5, you just write f equal 9 over 5 if you want, C plus 32, or I've seen other people giving me 9 C plus 32 over a 5, so that's the same thing, dividing the whole thing. So you get the same mark whether you give it like that or like that. Okay, so that's your third mark. Any question with this? We've just done the opposite of what was there in the first place. I had a takeaway, I've added. I had a divide by 9, I timed. I had a 5 time, I divided. And now I've got f is 9 over 5 C plus 32. So if my friend who's in America asked me what temperature it is, and I said 25, if that person has got this formula, they would put in their calculator 9 over 5, 25 plus 32, and they'll find out what it is, 25 degrees in Fahrenheit. And it is 9 over 5. So if someone is quite savvy with Fahrenheit, I'm getting 102.6. So if I tell you that it's about 103 degrees Fahrenheit in America, they'll know that, or me, it's 25 degrees. Okay, so that wasn't the question. These are just me trying to tell you why would you use a formula in math? What for? For that reason. Okay, so when you've got, calculator that automatically convert from one thing to another, basically the calculator is programmed with a wee algorithm that does this, for example. And when you type in one currency or one certain unit, then it converts it automatically for you in the other unit. Okay. Any question with this? So I went into detail step by step to show you how you would get those marks. Anyone struggle with this as you were going through? So the common mistake I saw was missing the brackets. Some people even went to do 9 times 32, that's fine. But remember, that's an extra line. So some people put 9c plus 288. That's perfectly correct. But remember what you do by doing 9c plus 288, you've added yourself an extra work. And anything that you do as extra, which is not giving you an extra mark, is a potential for you making a mistake. So when you don't need to do something, my word of advice is don't do it. Okay, I've seen someone typing 9 times 31 thinking they had typed 9 times 32. And they lost that last mark because they put 279. Yeah, but it's common mistake. So if I don't need something, I don't do it. Okay, so in the same order of idea, I've got here S. In the homework, some people put 5, and I'm going to show you why they put 5 instead of S. I want this formula to be rewritten, but with P. So if you want, you can switch 3P minus 4 on the left is equal to S. S, guy. Do you know why the person gave me 5? Because instead of writing S, the person wrote that. Can you see how this eventually, after a few lines, could be taken? Oh, that might be 5. So you need to be very careful when you work with letters and numbers. Okay, so that's probably not ideal, but there you go. This is S. So I've got a takeaway 4. What is the opposite of taking away 4? Adding 4. So you need to add 4 both sides to get rid of that takeaway 4. Then you end up with 3P equal S plus 4 and not 9, because S is not 5. No one told me that S was 5. Okay. That was mark number 1 for this one. So first mark. How do I get my second mark? I've got 3 times P. What's the opposite of timing by 3? Divide by 3 both sides. Now you could tell me, oh, why are you not putting brackets this time? Because I'm just going to do P equal S plus 4 over 3. And that is your second mark. So this question was 2 marks. Any questions? How we did it? Could we have given it into a different form? Yeah, if you had written or P equal a third S plus 4, you would get your mark as well. Or some people even give it as a third of S plus 4 over 3. Again, this is doing more work. That is not giving me any more marks, but you're allowed to write it as a third of S plus a third times 4, which is 4 over 3, or 4/3. Again, extra work, extra chance to make a mistake. Okay? But you got the mark. If you gave it correctly, obviously. Any questions for this one, the second one? Take away 4, add 4. Time by 3, divide by 3. 2 lines. And I can save myself even some ink on my paper. Okay, so those 2 questions were 5 marks, worth 5 marks. Now things are getting a bit more complicated with the third one, because I'm changing the subject of the formula to M, and I've got my M as a denominator. Okay, so again, it's up to you. You could decide you're going to write it on the left. So because we've started it that way, let's rewrite that. I've got W plus 50 over M squared equal h. So the first thing I need to do is to get rid of w, because I don't want w on the way there. Yeah. So to get rid of the w, remember w just means plus w, it's been added. What is the opposite of plus w? I'm going to take away w. So you need to do minus w for that side, but you do the same on that side too. Then your first mark is going to be writing 50 over m square equal h minus w, mark number 1. So whoever gave me that got that mark. Okay, so now there is a thing in math and solving equations is to get rid of a fraction. See, fraction does help, but sometimes if you want to get rid of a fraction, fraction just means divide by. So if I want to get rid of the divide by m square, I'm going to time by m square both sides. And that will get rid of my divide by m square here. So that means if I do 50m square divided by m square, what is anything divided by the same thing? And another thing I've noticed people sometimes forget, just put h minus w here as a fraction. And we said this time we're going to time by m square. So we've timed h minus w time m square. And that got rid of that m square, because anything divided by the same thing is just 1. So now to get m square on its own, I've got something time m square. I need to divide by that something both sides to get rid of that h minus w. So if I divide both sides by h minus w, which is what I'm going to do now, I'm getting 50 over h minus w equal m square. Forgot to say this was a second mark and this was your third mark. So m square equal 50 over h minus w. What is the function that undoes a square?
Square root.
Square root. Square root will undo your m square. Just think about it. If you've got 25, that is equal to 5 square. If I want 5 on its own, what do I need to do to 25? I need to take the square root of 25 to get 5 on its own. And square root of 25 is 5. That's how you get rid of the square, by taking the square root. So even if you couldn't remember, you can put that on the side of your paper. I've got 5 square, which is 25. How do I get rid of that square? By taking the square root. And that's the same thing we're going to do here. But if you take the square root, remember you take the square root on one side. So we're going to take the square root on that side. You need to take the square root on that side too. Now, I've got a fraction. You need to take a square root of the whole fraction, not just the top, like I've seen people doing. So to do that, you can rewrite 50 as a fraction over h minus w, but make your square root big enough to contain the whole thing. And that is m, which is your last mark here. So for folks who went and put square root of 50 like that over h minus w, and they had meant the whole thing, you don't get the mark because that should have been square root of the fraction itself, not just square root of 50, and then you divide by h minus w. Okay. Any question with that? That was question number 3.
No.
We happy? Okay, so let's move on to the next one. Next one was number 4. Change the subject of the formula to x. So I've got a square root of x there. As you can see, this is square root of x. So you can rewrite it as 5 plus 4 square root of x equal a. Now I've got an add-on 5. What's the opposite of adding 5? Taking away 5. So if I take away 5 to get my first mark, I end up with 4 root x equal a minus 5. 4 root x, guys, means 4 times root x. It doesn't mean 4th root of x, like I've seen some people writing. 4 root x is 4 times root x. So be careful. I've seen people writing that like that. Okay, so the next thing I want to get rid of is the 4. It's a time 4. What's the opposite of timing by 4? Divide by 4. Again, so that I'm not going to mess a minus 5. If you want, you can put the brackets there. So next thing is divide by 4 both sides. I get root x equal a minus 5. You know what? I'm going to put it with a big fraction bar divided by 4. 2 marks. If you stop here, you've passed that question because it's 2 out of 3. Now, we said earlier on, when I've got a square, to undo a square, use square root. If you've got a root, what is the inverse of squaring root? Squaring it. So that's the opposite. So I'm going to have to square both sides and just write x equal, so again, put the bracket a minus 5 over 4 is that whole side of that equation square. And that's your third mark. You don't need to do a minus 5 to the power time a minus 5. You don't have to. It's not going to give you any more marks. You don't have to make the 4 square, which is a 16. You can just leave it like that, and that's fine. But people that gave me a minus 5 square over 16, they got the mark. Unfortunately, the ones that gave me a minus 5 square over 4 didn't get the mark. Okay. Any question with this one? So these are the typical type of change in the formula question you will see. But we gave you an extra one just to kind of tease you and to show you this came up, I think, once in the past 10 years. It's very rare that you will see a change in the subject where they'll put both the letter that they want you to change the subject to at the top and at the bottom. But I'm going to show you how easy it is to do this one. Any question? think someone got quite close to finish it, number 5, but let's have a look. So the way they would probably put it nowadays is instead of writing it as b plus c over b, the exact same question could be asked as a equal 1 plus c over b. Can you tell me what's the difference between b plus c over b instead of 1 plus c over b? It's exactly the same thing. Because b plus c over b is just b over b plus c over b. And what did we say about when two numbers are the same and you divide them, you just get 1. So that has got the same denominator b as b plus c over b. So if one day you see this coming during an exam, it's going to be given like this. But there is a unit called fraction, manipulation of fraction. You're expected to know this. Okay. All right. So how do we do this? If it's given to me like this, I've got a divide by b. Some people started okay. How do I get rid of a divide? What did we say? To get rid of a, yeah, time it. So I'm going to time both sides by b to get rid of that b at the bottom. It's not going to get rid of anything that is at the top. It's just going to get rid of the b at the bottom. So if I time this by b, it will get rid of the b. But then because I've timed this side, I need to time this side as well. And this side become BA or capital AB. It's up to you. But look what I've got now. I've got something as BA equal B plus C. Yeah. So I want all the B's going into one side. That means I need to take away B here and take it away on this side as well. So BA minus B equals C. That's 2 marks. 2 marks. And this question was how many marks again? 1, 2, 3, 4. This question was 4 marks. By getting rid of that B as a fraction, I got my first mark. And then by collecting all the B's on one side, I got my second mark. Now I've got B, which is a common factor, because remember what I always said to you, when you've got a letter, it's the same as an invisible 1, B times 1. So I've got B times A minus B times 1. What is the common factor?
B.
B. And I just make it A minus 1 equals C. And guess what? This is your third mark. Now I've got B times something. What is the opposite of timing? I need to divide both sides by A minus 1 to get rid of that A minus 1. And if I do that, I will get rid of the A minus 1. I'll end up with my B on its own, C divided by A minus 1. And that is your fourth mark. So I think only one person came quite close and didn't get that last part. I think, yeah, the person got stuck with this. They couldn't see that you've got an invisible 1. Okay, because if I do BA, B times A and B times minus 1, I will get BA minus B, right? And if you had done all this, you would have got your 16 out of 16. But like I said, this is a challenging one. But you can see we can get a couple of marks from it. Okay. So what if you had decided to write it this way? What if you had decided, I'm going to rearrange this because I don't like B at the top and B at the bottom. Guess what? You just take away 1 first, A minus 1 equals C over B. Then you time by B both sides. Can you see now we've got your B times A minus 1, which is that one there, equal B and B disappear, equals C. So if you had rewritten that fraction as that, you would probably got the answer okay. And now you divide by A minus 1, and you could have got this like that. So which one is the simplest for you? I think the one on the right hand side, no? Do you not think so? But that means you need to know your fractions. Or are they as difficult one from the other one? No?
I don't know. I done mine completely different, so I'm a bit lost.
You lost on this part where we time by B both sides?
I don't know. Like I always just flip mine. So like I done so I got
So,
B plus C over B equals A,
so
and then
B plus C over B equal A, yeah? You started like that?
yeah, and then I times both sides by B.
So if I times by B both sides, that means I'm going to get rid of that B. So you must have got B plus C equal BA or AB, AB
I got,
or
well, this
BA.
is what, I think this is where I went wrong, because I got B squared plus C equals AB.
Oh,
Because
remember,
there's twice,
yeah,
but
what
that's where
you've
I've went
done,
wrong.
yeah, what you've done is when you time by B, you time that whole thing by B, but by doing that, you timed it to get rid of it.
Yeah.
And that got rid of it, but you've kind of kept it in. So
Yeah.
that's where
I put
you
it
went
there.
wrong.
So I should have
But
just had plus C equals AB.
but remember, even if you had put B squared plus C, right? So you would lose the mark there. But if you did the next stage okay, you would have got B squared.
Minus C.
That's
Well,
minus BA
yeah.
equal minus C.
Yeah, and then I divided that. Well, this is where I went wrong as well, because I divided that then by B, but I realised that I probably should have, because it was a square, I should have put that in the square root rather than like, because I
Yeah,
got B squared. But I know where I went wrong. But so see if I'd done it that way, would that still be right, even though I've kind of like moved the numbers about in a different order?
I think you probably would have got a mark by doing this, but that would have been it, because you wouldn't be able to now to write B on its own, because you can't, even if you square root that, you need to square root the whole thing, if you see what I mean. So then that should have told you, oh, there's something that I've done wrong somewhere. And then you would go, okay, now let's get back to this. And then you would have been able to see it maybe. Okay.
Yeah. Okay. Thanks.
No worries. Anyone else with a question on these? Okay, so let's try and move on then. So quadratic graphs is what you looked at last week. So we learned that if we draw equations in the form we get a parabola, yeah? So kx squared, you get a parabola. And then when you looked at using Desmos, by changing k, it just changed the steepness of your curve. So we looked at that last week. And then to find the turning point, we used to rewrite using what we call completing the square. So in order to find the turning point happens when this portion here equals 0. So if x plus p equals 0, that means x equals negative p. And that's why the turning point is x equals negative p. And then when this is 0, y equals q. Okay. So these expressions, whenever you get x squared in them, they are known as quadratic functions. So why do they call them quadratic functions? Quadratic comes from a Latin word quadratum, I think, which means square. So whenever you're going to have the x square here term that has got a factor in front of it different than 0, then you have a quadratic. So 5x squared is a quadratic. So if you were to draw that, you will get a quadratic function, like a parabola. If you draw x squared plus 3x minus 2, you will get a parabola as well. So when you've got this parabola, you've learned how to factorize x squared plus 3x minus 2. Remember when you were factorizing? We looked at two numbers such that a times b equal negative 2. And here a plus b equal 3. So I can use negative 3 and 1. No, that wouldn't work. So it needs to be 2 and 1. So negative, so it's got to be positive 2 and negative 1. That wouldn't work. So let's not worry about this one, because you might need minus b plus and minus square root of b squared minus 4ac to find it over 2a, the quadratic formula. So because we know that when we expand the brackets, we'll get a term in x squared, that is again a quadratic expression, because if you do x minus 1 square, you will get x squared minus x plus 1 plus 3. Yeah? So if I do x minus 1 times x minus 1 plus 3 and expand that, you will get x times x, which is x squared, minus x, then minus x, negative 1 times negative 1, positive 1, plus 3. And that is just x squared minus 2x plus 3. And that's why this is a quadratic as well, because you've got that x squared term in this. Plus 4, sorry. Plus 3 plus 1 is plus 4. Okay. Whereas, again, this one, x plus 3 times x minus 4, we get an x squared term. So that would be your x squared plus 3x minus 4x minus 12, which is x squared minus x minus 12. So again, another quadratic. So you can see that you can write a quadratic in different ways as long as you've got an x squared in your formula. Okay. Whereas these ones here, y equals 3x minus 2, that is the expression of a line, right? Remember y equals mx plus c. That is equation of a straight line. Here, because we've got another term with cube, it's a cubic expression. And we said these are not quadratics. All right. Any question with that? Okay. So quadratic function, what you're going to be learning this week is more to do with this. You will see that your quadratic functions comes in 3 different forms. So let's say the first form is x squared plus 4x plus 3, right? So let's say you have that as your first form. We've learned how to do completing the square. Remember what we were doing? We were halving this. So when we were completing the square, we used to write it as y equal x plus 2 square. But because you were adding 2 square, which is 4, you had to take it away, minus 4, and then you've got your plus 3. And that is just x plus 2 square minus 1. So this function here, x squared plus 4x plus 3, we've rewritten it in completing the form. And when you've got a completing the form function, you end up with what we call minimum turning points for this one. It's a minimum turning points because the factor here is positive. So think about positive smiley face. So your point here would be a minimum turning point. It's happening when x plus 2 equals 0. So that means x equal negative 2. And you get to a minimum when this part is 0, y is just negative 1. So you can check this out on Desmos. So if you were to put this function x squared plus 4x plus 3 on Desmos, it would come up like this. And you can see straight away, you've got a minimum there, negative 2, negative 1, which is what we mentioned when we use completing the square. Now, what else did we learn in Unit 1? How to factorize. Yeah. And I remember telling you guys, use what we call MAM. Anyone remember what MAM was? So you had M, A, M. So we are looking for 2 numbers. So we're going to rewrite this y as x plus or minus something times x plus and minus something. Those 2 here, I'm going to call them A and B. So I need to find A and B such that here I've got an invisible 1. M times M is 3. So I'm looking for 2 numbers such that M times M, which is A times B, equals 3. And if you add those two, A plus B, you get value here 4. So what are those 2 numbers? If I add them, I get 4. If I time them, I get 3. Can you give me 2 numbers? Someone said, yeah, 1 and 3. Because if you do 1 times 3, you will get 3. And if you do 1 plus 3, you will get 4. So then you put the 1 here. Your first number is 1. And the other number is 3. Because both are positive, 1 and 3, you just put plus 1 and plus 3. So in the factorized form, what we called the y-intercept, sorry, the x-intercept, it's when y equals 0. So when do you think y is going to be equal to 0? Is what we call the roots when this is equal to 0. So if x plus 1 equals 0, x equal negative 1. And the other one is x equal negative 3. And those are the roots. Because when x equal negative 1, I get y equals 0. And when x equal negative 3, I will get y equals 0. So in these 3 different forms, you can see how quickly you could draw your graph. Because I've got 2 roots. I've got what we call a minimum turning point. And the first one is dead easy, because if I'm looking for the y-intercept is when x equals 0. So what happened when x equals 0? What is the value of y? 0 squared is 0, plus 4 times 0 is 0, then y is just 3. So I've got two roots, a minimum turning point, and an intercept, and this is all they ask you to find when you draw a quadratic. And this is your y-intercept here, 0 and 3. So if you go to Desmos, you type y equal x squared plus 4x plus 3, you'll be able to identify the roots, -1, 0, -3, 0. You'll be able to identify the turning point and see that it's a minimum, and you'll be able to identify what we call the y-intercept. And that's what you are asked to do. From a basic trinomial equation, be able to find the turning point by completing the square, and be able to find the roots by factorizing your equation. And remember when I was telling you the first unit, ENF, is important because we're going to use it. And this is where we use it during the relationship unit. Any questions, guys? Before I give you the past paper question. No? So this was a past paper. I would say it's a model past paper, they call it. We were given a parabola called y equal -x squared. And we were told that the point -3 and k lies on the graph. So that means if x equal -3, then y equal k. So y equal k, x equal -3. What is the value of k? What is -3 square? Can someone remember?
9.
9. So because you've got a minus in front, then you get k equal -9. So the question was, find the value of k for this point -3k to lie on this y equal -x squared function by substituting y with k and x with -3. I've managed to get the value of k. Okay, so k equal -9. Now was it 1 mark. So again, if you get a question like this in an exam and you are struggling to find out, don't spend too much time, guys. The paper are going to be 40 or 45 or 50 marks. If you find yourself working on this for 5 minutes, just move on, okay? Spend 5 minutes on a question with 4 marks or 5 marks, not on a question with 1 mark. Come back to this one later on when you've got a, a more relaxed way of doing it. So k equal -9 is your answer. All right. So functions, I remember when we looked at functions, chapter 12, at the moment, don't worry about functions. Anything that says y is the same as f of x. So it's a function of x. So remember, whenever you had a graph, y, you give y as a function of x, but it's exactly the same thing. Okay. So what they mean by that is if f of x equal x squared, it's the same as y equal x squared. For every x, you've got a value for y. So if x equals 0, y equals 0. If x equal 1, y equal 1. If x equal 2, y equal 4. So that's how you build your function. So that's what they mean by function. So if you want to know more about functions, you can read back page 103 and 104 from your Lecky Lecky and just practice with 12C. Okay, so next week we will do a little functions exercise in the Zoom class with an associated homework. But don't worry what f of x means. Okay, so to finish up this week's lessons, you're going to do sketching quadratic function in the factorized form. So remember, a and b are going to be here my roots. That means when you're going to have a parabola, this is going to be a, this is going to be b. Roots is when y equals 0. You're going to sketch function with completing the square. That means when you've got negative p and q, you reach what we call a turning point. And then a maxima is more like this function, maximum turning point. Same thing here when you've got negative p and q. So that's what you'll do this week, 17a, 17b, 70c. And then question 18a is just to identifying those features. The intercept, the roots, the turning points. That works with that. Okay, so if you want to do more, there are Pegasus exercise there. And like I mentioned, the function exercise is optional. But if you want to know more about function, page 102 and 103 is what you would need to read. Okay, so there is a homework, week 11. Again, mixed exam type questions, which would probably get you to remember what you had done for the past. We're halfway through the year, so have a look. What do you remember? What you might need to work on again so that you keep tabbing on that. So it's not a bad one to do. And please, if you wait an hour before the deadline to do it, you know, it's not going to be as good as if you try and do a question at a time during the week and see, oh, I remember that. I remember how to do that. Or maybe I need to work more on that. It's more for you to be able to tune yourself to be in the best position moving forward. Okay. So someone had asked